This year is particularly meaningful for all of us because we celebrate the year of quantum science and quantum technologies. And many of you know that during October, the Nobel Prize was also awarded for groundbreaking work in quantum technologies. So it brings finally quantum science into the palm of the hand. Today we celebrate our first quantum hackathon. This event, as you see, is powered by Quantum Lithuania. I'm pleased to invite the director of the Center for Physical Sciences and Technology, Professor Ramūnas Skaudžius, who is the head of our hosting institution and will formally open our event.
Distinguished guests, partners, colleagues, and I would call friends in quantum field. And I would say it's a historic occasion. A historic occasion because we have the first time in the landscape of the Baltic states in the field of innovation, in the field of research. The first time we have quantum event organized hackathon in the Baltic states. Welcome to the future of quantum technologies.
First guest, so from Austria, one of the historical European leaders, especially when we talk about quantum optics, photonics, foundational quantum experiments. Vienna is legendary in this field. And it's my honor to introduce Professor Philipp Walter, leading figure in photonic quantum technologies.
So thank you so much. It's an honor to be here. I've seen remarkable progress and things going on here in your country. So I think I hope that this really is a kick-off moment for you guys to become part of the quantum technology journey that we will face around the globe. And I see you have everything in your hand here to become a strong leader in the European landscape and the global landscape even. Motivation of boosting machine learning or boosting photonic computers, we realized that space missions are very interesting. So in fact, there are more than 1,000 satellites flying around at the moment with computers on board. It's a cartoon, but it's a picture of a real satellite. We have here Lithuanian technology inside. We have a laser from Integrated Optics as a laser source for our designed payload.
Strict on time because taxi is already waiting for Philipp.
I'm sorry I have to run back to Vienna, but it's a true pleasure. Thank you so much for inviting me. I really enjoyed it a lot. I know it was a short time, but it's very, very, very impressive what you try to build up here, and I wish you all the best. And I see good reason everything will work out. It's
Thank you, Philipp.
Good morning, everyone. I'm from VTT, and VTT is non-profit, state-owned, independent research organization. Yes, we know how to use it, and we have been building the computer with IQM. And then we have software users and think with the end users what we would like to have in this continent.
Together with my group at the University of Copenhagen. And as a dessert for the keynote talks, I'll go out with a little bit of a physics moving forward along the development where the unknowns lie. And my claim is that one of the directions that one can take is to use Josephson junction arrays.
Us are still asking, not during our opening session, but still how close quantum opportunities truly are to real-world applications. And that is exactly why we initiated this entire panel. So we begin our discussion from theory to application, bridging quantum research and real-world impact.
I think that you need some, serial manufacturing robustness to improve quantum systems. Especially if we talk about photonics and lasers, I think there's a huge variety of quality parameters and stability that one can make out of a laser. More stable lasers will lead to more stable calculations in the quantum.
Before the perfection, there has to be some development in addition. Before you root into some processes, I think there has to be some development that leads before you can make a decision, and now you can root into those and start building rigid processes.
In my experience, I think maybe with regards to hardware, it's a slightly different path, and I can't speak on that. But as a researcher in industry in this field, I find that I end up doing just as much blue sky research as I did when I was in academia.
In quantum, they see the whole system and they can imagine the outcome of all of those moving parts.
Why I'm excited about it, because I'm working in this field.
Yes.
There's a reason I'm here, and there's a reason I want to keep working on it.
So we heard about the consequences of hype.
Exactly.
So we need to make more work together as well as explain quantum.
Grand finals, top 6 teams, presentations, and jury evaluation. The first team, HAKR Superposition, joining virtually from Riga Technical University from Latvia, presenting their solution to the quantum secure navigation challenge.
Our team, AGK and Superposition, has provided a solution for secure navigation for the quantum world, where the airplanes approach our capital Riga airport.
And scientific level, I know that Latvia is already participating in EuroQCI. Recently, Territory you sum up what you did in the 3 last years. So my question, is this solution originally proposed for this Quantaton, or it was adapted, let's say, from your previous experience which you gained from EuroQCI?
So this idea is obviously built on the previous experience in this EuroQCI.
I have a question regarding jamming of the signals, the communication with the airplane. Is your system immune to that? If yes, how so?
We are moving on. Second team, Kvantinių, joining virtually from KTH, Royal Institute of Technology, Sweden, presenting quantum network navigation, the quantum Hypersteiner optimizer.
So, hey everyone, we are Kvantinių. We assist navigation with quantum technologies. It is inherently systematic to the classical system of using our satellites with radio frequency signals.
How about more of some validations in terms of modeling? How it compares? How well you can achieve?
Yeah, thank you very much. Thank you for everyone here. It was an honor to participate.
Birantum, joining virtually from University Paris-Saclay, French, presenting smart grid, solving the energy trilemma.
Intelligence, and your presentation would have been perfect if you just showed, here is our algorithm working on simple computers. It takes, for example, 10 hours to check one drug. And here is using a quantum computer algorithm.
I have one question. So for me, this, I'm not an expert, but for me, this seems like an machine learning problem. Mm-hmm. I mean, do you really need quantum calculations to optimize?
Umbrella team, and someone told me that Vilnius University Faculty of Mathematics and Informatics is not on site, but virtually. Is it true? Team Umbrella.
Yes, hello everyone, we are online.
Topic, predicting drug toxicity with quantum machine learning.
Yes, hello everyone. So we basically tackled this problem which is very relevant to pharmaceutical industry.
What could be our solution? So what if we propose a tool which could avoid clinical trial expenses for already doomed candidates?
And you see, here in Vilnius, only in Vilnius, there are at least 2 startup companies which are fully operational who are already using artificial intelligence for new drug discoveries.
Next team is not today Eve, but they will present today. So, Vilnius University Faculty of Physics, Quantum Link Anywhere.
Okay, hello everyone. Let me thank organizers and the jury for the opportunity to present today in this hackathon. We are not today Eve, and we are from Faculty of Physics. Link Anywhere establishes quantum secure communication channels on demand using mobile quantum repeaters and drone deployed fibers.
First of all, very nice pitch. Some kind of, I was expecting someone is gonna, give a nice pitch. Eventually, like a high energy pitch.
Elements which you are using in your concept. And what if I will change this truck or car by another drone? Can you do this completely drone solution?
The last but not least, yes. So, Quantum Beacon is representing the Center for Physical Sciences and Technology, Lithuania, and where work or challenge is Quantum Navigation Challenge.
Okay, hello everyone. Thank you already for nice presentations before. If we already take into account the presentations that were already done, we can quite easily imagine that situation. But from a more comedical perspective, let's say you are traveling in another country and it's a difficult situation.
Right?
Yes.
Plus, what do you else have?
Basically, that's it.
Yeah.
That's all we need. So, because magnetic field is already in the Earth's framework, we don't need to invent anything new in this case.
Okay.
So just
nature gives it.
Nature gives us the logistical framework.
Yeah. already our discussions begin. So let's applause for our final round team.
Position from Latvia. Not today, Eve. So you get the heavy burden also to make your solution true. We found their solution closest to the market with the biggest impact to society. Let's congratulations for Quantum Beacon! Come, Quantum Beacon! Expectation in you. Congratulations again. Our jury has a special prize. 2 tickets to a conference in Latvia, Quantum Information Processing Conference. We established this prize thanks to our partners in Latvia, and we would like to present this prize to the team Umbrella. Umbrella, are you here?
We are here, we are very happy.
We believe that you will learn a lot in that conference.
So thank you once again for participating in the Quantum Boost. You had a whole month to solve the challenges and dive deeper a little bit into those subjects, and actually we had quite a lot of teams, and not all teams were able to finish those challenges. I'm really glad that you guys actually showed your competence and let's say resilience and thick skin to tackle those challenges.